We want to learn together about the emission spectroscopy. What is the emission spectroscopy? Emission spectroscopy is exclusively related to atoms, whereas a number of other spectroscopic techniques deal with molecules. It deals with atoms. Then fundamental fact of emission spectroscopy is very simple, wherein the atom present in a sample undergo excitation due to the absorption of either electrical or thermal energy. Subsequently, the radiation emitted by atoms in an excited sample is studied in an elaborated manner, both qualitatively and quantitatively. Therefore, emission spectroscopy is considered to be an useful analytical tool for the analysis of elemental analysis of metal, identification and quantitative determination of metallic elements, estimation of metalloid, for example, arsenic, silicon, selenium, present extremely low concentration, and analysis of solids, liquids, or gases as follows: solid, as such, or evaporated solutions; liquid atomized spray, analyzed occasionally; and gases analyzed rarely. In short, emission spectroscopy is considered to be the most accurate, precise, and reliable means of quantitative analysis of elements as on date. If proper skill, precaution, and wisdom are applied together, this method may be adopted safely and conventionally to analyze approximately 70 elements from the periodic tables at a concentration as low as 1 ppm part per million. The theoretical aspects of emission spectroscopy may be categorized into the following forehead, namely a spectra, a beam of light on being passed either through a nickel prism or a grating is split up right into a constituent array of colors frequently termed as a spectrum. However, the complete spectrum has a wide range that may be further divided into various regions based on their respective wavelengths 0 to 3500 angstrom. Ultraviolet region, it embraces radiation of wavelengths between 0 to 4000 angstrom, and visible range, it includes radiation of wavelengths between 4000 to 7300 angstrom, and infrared region, it has radiation of wavelengths between 7300 and 35,000 angstrom. This one also was 0 to 35,000 angstrom. Classes of spectra. There exist, in fact, two major types of spectra commonly termed as emission spectra and absorption spectra, which shall be discussed briefly as follows below. Emission spectra: an element on being heated to a very high temperature, either by electrical method or thermal method, usually emits light. This particular light, after passing through either a prism or grating when studied directly with the help of a spectroscope, give rise to a spectrum that is termed as emission spectrum. Absorption spectra: a source of light emits a continuous spectrum when first made to pass through an absorbing substances and subsequently through a spectroscope. It has been noticed that a few lines are missing in the observed spectrum, thereby leaving either dark bands or lines at their respective places. Because the light of wavelengths exactly corresponding to these dark bands or lines is found to be absorbed by the substances through which light is passed, or resulting spectrum is called as a absorption spectrum. About the classification of emission spectrum, the emission spectrum may be classified into the following three types, namely band spectrum or molecular spectrum. At each molecule, a pen excitation gives out a band spectrum or band that are characteristic of a molecule. In fact, a band spectrum comprise of groups of lines so near to one another that under normal circumstances they more or less seem to appear as continuous bands. However, in emission spectroscopy, the band spectra provided by molecules may be eliminated completely by giving energy to the corresponding molecules so that they may be split up into the spectra atoms. Continuous spectra, a continuous emission spectrum is obtained when solids are heated to incandescence. The thermal radiation of this nature is termed as black body radiation, which has the following three characteristic features, namely dependent more on the temperature of the emitting surface than the material of which the surface is made of, and B, caused by the innumerable atomic and molecular oscillations excited in the condensed solid by the thermal energy, and C, independent of the chemical composition of the substances. For example, in incandescent solid, for example, carbon and iron give rise to continuous emission spectra when they are heated until they glow. Hence, it is pertinent to mention here that the continuous spectrum cannot be employed effectively for spectrochemical analysis, and these spectra may be eliminated completely by volatilizing the material. Sample before excitation. Line spectra, the third part, line spectra. Line spectra are usually encountered when the light emitting substance, that means the radiation species, are separate atomic entity particles which are distinctly separated from one another, as in gas. Therefore, it is invariably known as atomic spectrum. As the line spectrum depends solely upon the types of an atom, hence it enjoys the status of predominant type of emission spectroscopy. Bohr theory rightly explains the fundamental origin of line spectrum, according to which an atom in the ground state has its electron present in the lowest permitted energy level. An excited atom by the thermal or electrical means has its electron migrate from inner orbitals, specifically valence electron, to outer orbitals. The excited electrons quickly give a photon of energy of immediately take the position in an orbital having the lowest energy or ground state, and the emission of radiation from the excited atoms give rise to distinct spectral line, thereby forming the basis of emission spectroscopy. You see, on this figure, energy level diagrams for an atom and molecule depicting the source of line spectrum and the band spectrum. This is a line spectrum. This is a band spectrum. This is a ground state, energy level 1, energy level 2. This is the excitation, and this is the atomic emission. From the ground 1, the electrons coming here, and the electron is excited. Electronic excited is the lambda bond, lambda 1, lambda 2. Thermal or electrical energy, they are coming up, they are coming down, and this is a band 1, this is a band 2. The G is the horizontal line represent the ground state energy, the lowest energy of an atom, say sodium atom, and E1 and E2 represent the two higher energy, the electronic levels of the atom, say natrium atom here. For the sodium atom, natrium atom, the single outer electron in the lowest ground state G is situated in the 3s orbital. Consequently, the energy level E1 might designate the energy of the atom when the single electron has been duly raised to the 3p state by virtue of its absorption of a thermal, electrical, or radiant energy. This phenomenon has been clearly shown with the help of the dotted line in the figure. However, the atom ultimately gets back to its ground state, maybe after 10 to the minus 8 S, thereby emitting radiation whose frequency is given by the following expression. Nu1 or V1 is equal to E1 minus G multiplied by H, and the lambda 1 is equal to Hc. The Planck, remember that was the Plankton constant multiplied by C divided by E1 minus G. Okay, I don't continue furthermore because of the copyright of this book reserved, but you can buy this book or get this book by yourself and use it. This is so useful. It has everything you needed. In this part, it's coming to the electrode, self electrode, graphite electrode. Here it has a monochromator, it has a detectors here, and you can by yourself read it. This is a litho 2 spectrograph. It has also the application of emission spectroscopy. What is the application, theoretical and recommended radiation also here. I hope my video was useful for you. If you have any question, make a comment for me. I help you also in the pharmaceutical analysis. Have a good time.